Okay, today in lab, you are not here, so we're going to have to do this virtually. What we're going to do is study refraction. And when you get to class sometime, eventually, we'll show you this with some laser beams and some jello. But for right now, you're going to take my word for it. So we are going to use a little app to show us what happens when a laser beam passes from one medium into another. So we're going to click on Intro here when you go to the app, and we're going to do two experiments. The first one we're going to do is we're going to look at what is called refraction. So I have a laser beam right here, and I can turn it on by pushing the red button, and I can move it around. And one of the things that happens when a laser beam or a beam of light strikes an interface, so this is air, and down here we have water, and you can set that over with these. So I have air, and if I had air and air, then the light beam would just go straight, okay? But if I go from air into water, so this is water, then the light beam actually bends. And the bending of light when it passes from one medium into another is called refraction. Okay, now remember, a medium is something that a disturbance or a wave travels through. So the wave travels through air, and then when it goes into water, it bends. And how much it bends depends on its angle. So you are going to do an experiment. So in your lab, you are going to change the angle of incidence, and you are going to measure the angle of refraction. Okay, so let's talk about what those are. We are going to represent, whoops, wrong window. We're going to use the angle. So this is the interface right here between the air and the water. And we're going to draw a line that is perpendicular. That's the line, that perpendicular line, we call it the normal line, we're going to use to measure the angles. So I'm going to grab my protractor over here, and I'm going to put it right smack in the middle. And you've got to do this pretty carefully or you're going to have bad data. Make sure that 0 is right on this line and 90 is right on that line. Okay, you got to get that lined up. So make this full screen when you do it, and make sure you get it all nice and carefully lined up. Okay, now the angle of incidence is the angle between the normal and the laser beam. So right now that's 30 degrees from here to here. That's the angle of incidence. And what you are going to measure is the angle of refraction. Okay? Now, to set this up, your lab sheet is going to tell you what index of refraction to use over here, because depending on what index of refraction I use, the light will bend different amounts. So everybody's going to have air for the top. That's going to be 1. And then we'll talk about what this index of refraction means when we get to class tomorrow, hopefully. But right now, just make sure you set it whatever you're supposed to in the lab. So in the lab, you will put in the month you're born, and that will tell you what to use for the index of refraction for the lower media. So whatever it is, make sure you do that. Okay, so I'm supposed to be 1.48 here. So there we go, 1.48. Okay, so the angle of refraction in this case is the angle of incidence is 30 degrees. The angle of incidence is the angle the laser beam comes in at. And the angle of refraction would be, here's 10, there's 15. It looks like right at 20 in this case, okay? So what you're going to do is you're going to change this. You're going to start at 0. So when the angle of incidence is 0, the angle of refraction is 0. Then you're going to go to 10 degrees. So very carefully make sure that's on 10 degrees there, and measure the angle of refraction. In this case, it's between 5 and 10. So you're going to, for each angle here, 0, 10, 20, 30, all the way down to 80 degrees, you're going to measure the angle of refraction. Okay? Once you collect your data, you're going to find a math model. I'm going to give you a hint because this math model is not like one we've done before. You're going to take your calculator, and to find the math model, you're going to take the sine of the angle of incidence. So in your calculator, there's a function called sine. You're going to take the sine of 0, and that's actually 0. And you're going to take the sine of this angle and put it there. So you're going to use your calculator, and you're going to find the sine of the angles here. And that's what you're going to graph. And so the relationship you have on the x-axis, you'll have the sine of the angle of incidence. And on the y-axis, you'll have the sine of the angle of refraction. And you're going to look for a relationship between these two things right here, okay? So if you need any help, I'll be glad to help you. Just send me an email or pop online. I'll be available online till about 2:30 and then by email after that. but don't wait till the last minute. All right, so that's part A of the lab. You're going to ask, how does light bend? So you're going to, for each angle of incidence, the angle of incidence is this angle right here, that's 20 degrees. You're going to measure the angle of refraction and then try to find a math model. The second part of the lab, you're going to investigate the intensity of the light, because you notice here that some of the light is bouncing off the interface here. So you may notice that even when you look out your window, there's a little tiny bit of a glare. Some of the light that hits your window gets bounced back, and so you can see a weak reflection of yourself in your window. And we're going to measure how much of that light is refracted and how much of it is reflected. So in part B of your lab, for each angle of incidence, you're going to measure the intensity of the reflected beam and the refracted beam. So the way you do that for part B is this. For any given angle, you can grab an intensity meter and you can put the inspector right here. And so when I'm at 30 degrees right here, you can see that 5.41% of the light is reflected. It bounces off and comes back. Put it down here and you can see that 94.59% is transmitted. 94% of the light goes through into the water, or whatever this is. And so you're going to record those two in your data table. All right, so in your data table, the amount that's reflected goes here, the amount that's refracted goes there. Those are both percentages. And you'll do that for each angle up to 80 degrees. So again, you will change the angle, set it from 10 to 20 to 30 to 40 to 50, and each time use the inspector to measure the reflected intensity. So now you can see there's 17% reflected, and measure the refracted intensity, the intensity of the light that goes into the material down here. For the second part of lab, you're just going to plot your data, put titles and labels on. You are not going to find a math model, okay? It's actually a really complicated equation called the Fresnel equation, but we're not going to examine the mathematical model, okay? I just want you to see the pattern of what's going on here. So that's part B of your lab. And then when you're all done, get that turned in, okay? All right, that's your job for today. Let me know if I can help you.